All right, so DNA replication is the main topic of this section, but to be honest with you, you can't get away with this without going back to the cell cycle. Something you were hoping to have forgotten by now, and yet here it comes again. Uh, just as a quick recap, there's two phases: there's interphase and mitotic phase. An interphase, that's the non-replicating section. You have G1S and G2, right? And that is your interphase. And in S, you copy your DNA. So that's what we're talking about here: is the replication of DNA and how that happens and what that looks like. And the idea is you're going to go from one set of DNA, one copy of mom and one copy of dad for chromosome 7 or whatever, to two copies of it. Okay, that's very important so that both cells after cell division has a complete set of DNA, and that all happens in the S stage. And I'll try it here. So DNA is a template, right? It gives you the information you need in order to make the new copy. As a template, okay, what is really neat here, what works really well, is that you can make a copy of the top half and of the bottom half at the same time. So it can speed up DNA replication a lot because you have a lot of DNA, a lot more than I want to try to explain to you here. But let's just say you have more than you and I could count. If we were to count all the bases you have, all the nitrogen bases that you have in every nucleotide, you would die of old age and not even get close to finishing. That's just in one cell. So you need to do this a little quickly. We use enzymes that will speed up this copying process, and we do it in both directions. So here's an enzyme at work, and we know what's pretty cool about these enzymes is, for example, if this green is A, we know what goes with A is T. So this enzyme will find a T and put it where the A is. If this is a C, it'll find a G, right? So if it's Charlie, it'll find a golf to make those two things connect. Now, for those of you who are going to be like, wait, what's Charlie and what's golf? Those are the letters, the words we use to associate the letters C and G, because those two tend to sound similar. So Charlie and golf. Same on this side. And the enzyme is called DNA polymerase. Anything that ends in ACE is an enzyme. So this is an enzyme that speeds up this copying process. So here is your DNA polymerase kind of zoomed in. CG, GC, TA, CG. Here's a T. Here comes an A. There's DNA polymerase coming in. Now, DNA polymerase is in charge of attaching the next one that goes in that matches the letters that are here. But it doesn't work alone. Helicase also is involved. And what helicase does is it separates, it unzips the zipper of the DNA. See how this DNA used to be connected? It's going to unzip it all the way up so that it becomes two separate strands. And that'll allow for each side to be copied. So this is called a semi-conservative copying process. It's a big word for a simple idea. You have an original strand and the new strand that you just created, and they're both connected to each other. And you end up with two molecules of DNA. The reason, remember I told you it goes in both ways. It doesn't just go in both ways from one spot. It goes in both ways from 1, 2, 3 spots, right? Or 1, 2, 3, 4, 5, 6, 7, 100 spots. The idea is that you want to do this as quickly as possible because there's so much DNA. You cannot wait to, go from there. And with that speed might come with some errors, but DNA can fix and find and fix some errors. Okay, not all. It can't fix everything, but it can fix some of them. And believe it or not, that is it for Chapter 8, Section 3.